Number 4, please raise your hand if you have a question. You will be unmuted, or I will call your name for you to ask your question. And when you ask your question, I will give you an answer. Next, we will not tolerate vulgarity. This one again speaks to number 1 of saying, please let us respect each other. And lastly, please let's not take a learning opportunity away from someone else. Please let's respect each other's right and need to learn. As I always say, these are trying times and we are all doing our best to stay afloat. So let's allow everyone to be able to get through this time. Okay, so what are we going to go through today? We had started yesterday with our reduction formulae. Hello? Okay, guys, I think I went on mute there for a second, but I'm here now. So we had started with reduction formula yesterday, and we will be continuing with that. By the end of today's lesson, we will have created what looks like a reduction formula summary per quadrant. We will do some working examples on reduction formulae, and I will be giving you guys a few practice examples to go through, which we will then revise together on Monday. So I had a request from yesterday's class. So I had given some practice examples on Wednesday, and I had a request yesterday's class to prove the side differently. I'd like to do that, please, first, and so that we can continue with today's lesson. So what I had done yesterday, to those of you who are not here, we were proving some equations, proving the left-hand side being equal to the right-hand side. A lot of people were actually asking me why I was proving the left-hand side each time. And I had said, I just happened to be proving the left-hand side because the left-hand side tended to be a bit more complicated than the right-hand side. I had said that my method of doing formulae is to say, try and take the more complex side and make it equal the more simplified side. And in some cases, you do have to, or you do find yourself simplifying both sides, right? So in yesterday's class, I simplified the left-hand side. What I'm going to do quickly is today simplify the right-hand side to show you guys then how to make the right hand, how to prove the right hand equal to the left hand, right? So what I've done, the first step in this case, as I'd mentioned, is to say that you have to get your denominator at least starting to look like the other side. So when you look at your left-hand side, on your left-hand side, you have a cos denominator. On your right-hand side, you have a sine denominator. So what do we do to get onto common ground? We start by multiplying by 1. I multiplied by cos A over cos A, which is the equivalent of multiplying by 1, and therefore has minimal, well, no impact on the meaning of the formula, but it does give us a cos in our denominator. So here we are, we multiplied our cos over 1 plus sine A times 1, cos A over cos A, or which is times 1. From that, we do our usual multiplication of our fractions, have cos A times cos A over 1 plus sine A or times cos A. And that gives us this result here where you have your cos squared A over cos A times 1 plus sine A. When we have that, we will apologies, guys. When we have that, we have now applied our reduction formula, which our Pythagorean identity, which states that sine squared A plus cos squared A is equal to 1. So we have translated cos squared A into 1 minus sine squared A. We did that simply so that we could start having a view of the sine function in our numerator as well. From here, this is your factorization, which is split up back into your two brackets, where you have 1 times 1, 1 times minus sine A, 1 sine A times 1, and, which puts us at, which then you will cancel your denominator, that your commonalities in your numerator and your denominator, because the impact of that would be 1. And that leaves us, ladies and gentlemen, with 1 minus sine A over cos A, which is equal, which makes your left-hand side equal to your right-hand side. So I hope I've answered to yesterday's request for a swap around of proving the right. In the interest of time, I will be moving on. If there are any pertinent questions, please do go ahead, guys. Please stop me as we move along. Right, so I've kind of tried to summarize a few of the reduction rules. There's a few reduction rules that I believe we generally come across as we do the work. This comes from looking at your Cartesian plane and looking at available alternatives to express things. Our first rule says that the reduction formula is true for any angle, and for today we'll be calling our angle beta. For our convenience, we will always assume beta to be an acute angle. Why are we working with an acute angle? Simply because our Cartesian plane splits at 90-degree points. And when you use anything more than 90, you moved on to the next quadrant, which for today's lesson is not what we're trying to do. We're trying to instill and solidify the principles per quadrant, and then we'll move on from there. Right. So when determining the function values using a plus or a 180 plus or minus beta, 360 plus or minus beta, and when you have a minus beta, the function doesn't change. What do I mean by that? I simply mean that sine of 180 plus beta becomes minus sine A, so your function has remained the same, and the same is true for tan of 360 minus beta. The function remains the same. We will get more into depth on this as we move along. Then you have your Coco rule. Your Coco rule applies when your function is expressed as a 90 plus or a minus beta. So as you can see from yesterday's little Cartesian plane that we did, we are basically talking about whatever happens in your first and your second quadrant. What do we mean by this? We are saying that sine of 90 plus beta is the same. It changes the function completely to cos of 90 plus beta. Remember, cos is the co-function for sine, and equally, your sine of 90 minus beta has changed our function to cos beta. Hoping that makes sense, but as we go along, we will see that in play. Right, so this was the quadrant that we were working in yesterday, and what I had attempted to do yesterday was to give you guys almost a summarized view of your function, of these little babies, of your little expressions. We tried to say, in your first quadrant, you would express your angle as 90 minus x. Your first quadrant goes as far as 90. Your first quadrant gives you an acute angle, right? The second quadrant, you could express it in one of two ways, or it will be given to you in one of two ways. You have 180 minus x, x obviously then being, apologies guys, x being in a 90-degree range between being less than 180 and more than 90, or it could be expressed as 90 plus x. And so that means anything from this point on in that direction. The same is true for quadrant 3, where you have 180 plus x, meaning we're starting at this point and we're adding x each time. We're adding an angle from your protractor, and you have your 270 minus, meaning we're starting from this point and you are subtracting a point each time moving backwards on your protractor. Then finally, our quadrant 4 is a 316 minus x, saying we are moving from this point and we are moving that way. A reminder here again that our x / our beta, for purposes of getting the point across, is an acute angle. Is everybody happy with that? Can we continue? I see no questions, no hands raised. I'll take it that we are all good. Right, guys. So this is a small, quick example because I know that you've kind of touched on reduction formula in grade 10. What I'm asking us to do here as a class is spot the knot. I've basically come and I've put in different examples into the different quadrants. And I like to do this exercise with you guys. As I had said, we're moving to a place where interaction is becoming crucial, just so I can get an understanding of whether you guys are feeling what I'm saying, whether you guys are hearing me, whether we're all learning. And I just generally need your assistance in getting through because, hey guys, I'm actually used to just working with a projector and a pen. And so working with PowerPoint, we have errors here and there. And who knows, it might be an error, it might be a test. I just need your assistance to identify it. And so in this case, I'm saying to you guys, given what I've told you, given how we've looked at the split of the Cartesian plane, is anybody willing to please assist me spot the knot? By the knot, I mean the incorrectly placed expression. What I mean is in each of these, all the expressions are representative of, number one, the quadrant that they should be in, number two, in the quadrant where they are positive. And so which of these comes through incorrectly? Does anybody know? Can anybody see? Any takers for that? Oh, guys, I see there's no takers for that. Oh, I see. Lutaba, please assist us with this one. I see you've raised your hand. Please assist us and tell us which one it is.
On the first quadrant,
First quadrant,
we have 90 plus beta.
Oh, sine 90 plus beta, that one.
Yes, it should be on the second.
Ma'am, thank you so much. That is absolutely correct. Sine 90 plus beta should be in the second quadrant because 90 plus beta begins in this quadrant. Thank you very much, Nobutaba. Thank you for your participation. And so, yes, guys, that is where you would correct that. Moving on, we have a few simplified examples of how we will be applying the reduction formula. Please engage me, guys. Please stop me. As I had said, we're all here to learn and understand, right? Here's our first example. We are going to be simplifying tan of 180 minus b, sine of beta, and cos of 180 plus beta. Does anybody feel that I moved too quickly to the examples and I need to go back to summarizing our view on functions? No. Oh, okay. I see I have a hand raised. Chris Vic.
Yes, ma'am.
Yes. Would you like me to do a quick recap on how everything converts, or is that why you raised your hand, or do you have a question?
I'd like you to recap if okay with you, ma'am.
All right. I'm going to go back and I'm going to be using this little quadrant, our apologies, and I'll be using this for us. Okay, so remember yesterday, guys, we had said that our quadrant, our expressions or our functions are positive in all our functions are positive in quadrant 1. And I had given you guys a little short sentence that I was taught when I was kind of learning to tutor. They had said this is a very smart trigonometry class. So at this point, A stands for all, which means all angles are positive in quadrant 1. S stands for sine, meaning only sine functions are positive in quadrant 2. T stands for tan, meaning all tan functions are positive in quadrant 3. And C stands for your cos, meaning all cos functions are positive in quadrant 4. We have a question from Jerusha and hand raised. Jerusha.
You are unmuted, Jerusha.
Hi, Jerusha. Please check that your computer isn't on mute.
It seems we are unable to unmute her.
Okay, Jerusha, please send us in a chat, a message in the chat, and then we will get to your question. So in the meantime, we are going to continue to say what we had discussed yesterday, saying that all the sine functions are positive in here, means that in quadrant 2, means that every function in quadrant 2 is negative. So if you, for example, have a sine of 180 minus x, sine of 180 minus x is equal to sine x. The sine of the cos of 180 minus x, however, is going to be equal to 180, or is going to be equal to minus cos of x, right? So that expression, your cos, becomes negative in this quadrant. I'm going to ask you, Chris Vic, to please go back onto YouTube to yesterday's class just to get a proper breakdown of how we got to that. But a summarized thing is to say, a summarized cos and sine. When we're talking cos and sine, when we're talking about a 90-degree angle, or 90 minus 90 plus, we are able to interuse your cofunction. We actually have to interuse cofunctions. So the sine of 90 minus x is actually equal to the cos of x. So when we are reducing, basically, fundamentally, when we are reducing, we are trying to express everything as x. We are trying to remove this here part of your formula because, or your expression, because these points of the expression are basically equivalent to the naught lines, the 0 lines. They all pass through each other at a point where they are an origin. And so when you are reducing, you are basically looking to eliminate that and express your function straightforward as a function, expressing a function as a function of x only. Just to catch up with that, I'm going to ask you, please, Kushvik, to go back to yesterday's class to understand why we do that. I do hope for now you will be able to keep up, but please, I'm still going to be welcoming your questions and you can stop us here and there. Happy? No questions? So I'll take it that you're happy. Right, guys. This is our first example. So amongst the rules that we have created in the class for the new joiners, we have said that whenever you see cot, whenever you see tan, try to simplify it or express it using sine and cos. So we had come slowly, we built on our trig functions, our quotient identities, reciprocal identities, and Pythagorean identities that have allowed us to learn how to simplify basically our numbers. So here, our starting point and our point of focus today is to reduce all of this. As I had mentioned, reducing means trying to remove this because this almost serves as a 0 point on a Cartesian plane. So our first step in trying to reduce tan of 180 minus beta is to say it's minus tan beta. Why is it minus tan beta? 180 minus beta actually sits in the second quadrant. Tan is negative in the second quadrant because only sine is positive in the second quadrant. And so that is why we have that negative in there, and we have eliminated that, and we're using tan beta. Sine beta, we bring that forth as it is sine beta. And then for cos beta, cos of 180 plus beta, 180 plus beta, if you go back to our Cartesian plane, is the third quadrant. And in the third quadrant, only your tan functions are positive. And so that means your cos is negative in quadrant 3. So it's negative cos beta. Right? From here, we multiply and we continue as it is a straightforward multiplication. We then change our tan function to a simplified sine and cos. This is one of the identities we learned with our classes as we were working through, and we're finding ourselves at minus sine beta over cos beta times sine beta times minus cos beta. From here on out already, you can see that we are simply able to multiply this, we able to cancel out this denominator by this numerator. We are able, and that brings us to a sine times sine. We are also able to cancel out this minus times this minus. They become a positive, and so that turns our number into, our expression into a positive expression. And at this point, we are finding ourselves with a final answer. So that and that are going to cancel each other out. We're finding ourselves with a final answer for sine beta times sine beta, which is sine squared beta. And at this point, we have then simplified our expression. Basically, in substance, when we say simplify, when we say reduce, what we're saying is bring your equation or your formula down to as simplified an expression as possible without any of these functions or function values where you have a range. Everybody happy? Any questions before I move on to the next example? Okay, there's been no hands raised, nothing in the chat, so I'll take it that everybody is happy and I'll move on to our next example. Our next example says cos squared of 180 minus beta plus sine squared of 180 plus beta. So right away, we are working with squares, but squares are never a train smash. A square just squares, it multiplies an entire bracket by itself, right? So here we have cos of 180 minus beta. Remember, guys, 180 minus beta is in which quadrant? It's in the second quadrant. Cos is, only sine is positive in the second quadrant, so cos is negative. And so basically and this side we have a sine. 180 plus beta is an expression in the third quadrant. And so sine in the third quadrant is also negative. So our next step looks something like saying we have a minus cos because this is the second quadrant and it's squared beta. And if you could express this for what it actually is, you would have written it as minus cos squared beta. Oh, cos beta, my bad. Minus cos beta squared. And the same is true for this. You would have simply expressed this as minus sine beta squared. Remember, when you have a square on a negative, it simply becomes a positive, and I want to erase all this. Let's see. Okay, as my eraser is missing in action, but yeah, Let's see. My razor seems to be missing in action. Unavailable to me at the moment, so I'll just try and work without it, and we'll say what you are then left with is when you cancel out your subtractions, you are left with a cos squared beta plus a sine squared beta. And this, ladies and gentlemen, goes back to our quotient identities that we learned this week. And we know that cos squared beta plus sine squared beta, it's a Pythagorean identity, is equal to 1. So example 2, we've gone as far as to simplify yet again. Is everyone happy? Is everybody understanding? Are we all good? Any questions? So I'm basically moving to our final example now, and I'm hoping someone can take me up to assist me, show you the example. So if you feel like it's so that you can be comfortable with what you're seeing and assist me knowingly. Is anybody willing to assist me with our third example? This is our last example. Any takers? The purpose is to try and reduce and simplify. I'd just like you to talk to me through the steps of how we're doing this, when are we applying what, how are we doing this, and how we're going to simplify this. Promise, guys, I don't bite. I'm just asking for assistance so that I can know that we're all on the same page, we're all doing well. And I think it just sounds better when you hear the voice of your peers. Any takers to assist? Oh, Nogutaba. Yes, thank you. Thank you for volunteering to assist. So we're going to do this step by step. I'm going to, like I always say, I like to learn from you guys because you guys actually think different. You guys are actual wild thinkers. So please take me through how you would go about this. From here on out, what would your next step be?
Well, 180 plus beta.
Mm-hmm.
180 plus beta is on the third quadrant, whereby tan is positive.
Yes.
So it becomes tan beta.
Tan beta. Nice.
Yes.
Right. And then?
As for cos 180 minus beta, it's on the second quadrant, whereby sine is positive.
We are doing.
So it becomes.
Are we doing this one?
Yes. No. The cos 180 minus beta.
Okay.
Yes. So it's negative cos beta.
It becomes negative cos beta, you say?
Yes.
Okay. Something like that.
Yes.
Right.
And then as we go to our denominator, we have sine 180 minus beta.
Yes.
180 minus x is on the second quadrant, whereby sine is positive.
Yes.
So it becomes sine beta.
Sine beta. Yes. Lovely. And from here?
Then going forward, I'm not sure.
Okay. So thank you, Muktaba. You've taken us actually through the most important step. So what you have done with us, you have completed today's purpose, which was to reduce. Thank you so much for volunteering. Thank you for taking me through how you did it. Loved it. And I agree with you right there. That's your next step. So from here on out, my rule was to say, always try to simplify tan to a function of sine and cos. So tan then becomes sine over cos, sine beta over cos beta, and minus cos beta over sine beta. So remember, whenever you are multiplying by a fraction, so denominator of one cancels out the numerator of the other if they look the same. So what's going to happen here? This is going to cancel this out, and you're going to be left with sine beta up here. Down here, you are left with sine beta. And so sine beta over sine beta. Oh, you have a negative, your negative. Your negative has not disappeared. Apologies for that, guys. So up here, you have your minus sine of beta over sine beta, which leaves you at -1. Happy, everybody? Anybody with a suggestion on how we could have done this differently? Nogutaba, thank you. You've done this perfectly for me. You have achieved the purpose of the class. This was to reduce our functions. I have a question from Bronwyn. Hi, Bronwyn.
Bronwyn, you can talk. Bronwyn, you can talk.
Sure. Bronwyn, I'm going to ask you to please text us your question because we seem to then be missing sound in terms of we're having probably trouble with unmuting you guys. So I'm going to ask you please to send us your question in the chat and I'll happily oblige and answer. Otherwise, you're also happy to contact me on Twitter if you want to take it offline. Apologies for that, Bronwyn. Right. So today's class was relatively simple. We were deriving. What have we basically done? We started this class yesterday, right? We just created a summary of all the quadrants and the functions per quadrant. We learned about the COCO rule. We got to apply it here and there. We have to remember that in our first quadrant, everything is positive. In our second quadrant, every only sign is positive and the like. Remember, these expressions over here indicate to you the quadrant that we are working in, and that's how you knowingly place your stuff. Guys, did you guys know that the co-function for tan is cot? Just finding out from you guys, just out of interest, did you guys know that? Because it seems like a lot of people didn't. So yes, the co-function for cot is tan and vice versa. Remember what we had said when we started the class? We said in quadrant 1 and 2, where your expression has a 90 in it. So whether we are talking 90 plus or 90 minus x or beta or whatnot, your function then changes to the co-function. And that's why over here, we have it as cot. Remember, tan is negative in this quadrant. And over here, we have it as tan, and it's negative in this quadrant. The same applies here where you have cos. Cos is negative in the second quadrant, but because of a 90 function, then we use the co-function, which is sine. Right? So that's, guys, literally a summary of what we've done today. I have a few questions for you guys to do. These are the questions that we're doing through Monday's class. We're sitting on questions on Monday class to solidify reduction formulae, to pick up on your guys' issues. Please do these questions so that you can pick up on any issues. I would love if you guys can come on Monday armed with your questions. That would kind of make us, it would make the interaction feel better. One, it would take us through the actual understanding of reduction formulas and my understanding of your understanding. And so I will just give you practice examples. So quickly, just to wrap up here we say sine is negative in the third quadrant. And here we have our negative and we've simplified. Tan is positive in our third quadrant. And here we have tan and it's simplified. So really, guys, that is ultimately the summary of your reduction formula. You always look at which Cartesian plane you're working on. You look at the expression that you're working with. As I previously said to you, that we get taught a lot using we use 90, we use 180, and we use 360. When you come across a 270, remember which quadrant 270 belongs in? It belongs in this quadrant over here. The same way 90 belongs in this quadrant over here. And if you find yourself finding something like a 360, it means you're going to go around to 360. If you find yourself finding something like a 540 is what I meant, it means you're going to go around to 360 one time. So when you say 340 minus 540 minus 360, it would mean that you have come around full circle and then the rest is your top up. So you'd say plus 180. So that would drive you back to here. And so you would basically eliminate the 360 because it brings you back to 0, and you would look at it as a 180. We'll go again in more detail on that when we go through our practice examples. I'd like to give you guys enough time to write down the practice examples. So these are our practice examples. And my instruction on these 4 examples is as far as to say, guys, for your homework, please try to simplify these. We'll go through them on Monday. Some of them look slightly tricky, like where I have said minus 180, minus 180. Guys, it is not an error. It is deliberate. It is part of how we are testing your ability to understand a reduction formula. My style of teaching, guys, is the kind where I'd like for you to learn how to learn and not cram the answers. I'm hoping that we are well on our way to that. So while that continues, while you guys are writing down your, let's call it homework, while you guys are writing down your homework, I'd just like to continue forth with the lesson because we're running out of time, to say to you guys, please guys, your participation, the success of this class depends on your participation. I need you guys to interact with me so that we know that we're on the same page. We cannot interact physically. I think maths is always best when we are sitting opposite each other. But under the given circumstances, I'd like you guys to ask you guys to please use this platform to ask questions, to get clarity, because grade 11 is the solidifying year before you top up in your grade 12. My favorite line to also say in this class is, whatever your religious practice, stay with that. Stay grounded and stay sane, guys. We are all in a very tough time, and we need to do everything we can to keep afloat. Say your prayers, guys. Drink your water. Be kind, be polite, because we are all going through something, and take care of yourselves, right? I'm going to take it that you've written everything down. The class will be up on YouTube should you need to go back and revisit this because you didn't get a chance to write everything. But I'm sure you can even take a screenshot. I always post helpful links that you guys can go to. Siavula gives you great examples of the lesson that we were doing. And on Khan, you are able to get nice quizzes for that you can go through. And what will we be doing on Monday? We are simply going to be going through our homework, our practice questions. We're going to be focusing on that, doing that. And if time will allow, we will start on double angles and half angles. As I had mentioned, trigonometry is relatively a lengthy topic, so we'll be doing it over a few lessons. To the guys that are starting today or started yesterday, please go back onto YouTube to find the pre-recorded lessons, the videos of the lessons, just so you can come back and catch up to where we are. Please, guys, be comfortable to contact me on Twitter with any of your questions. I will oblige. I will assist where I can. And yeah, I am Miss Shabalala. It was great having you for my first week, guys. Thank you for welcoming me. Thank you for taking part in the class. I sincerely hope you guys will grow and benefit from this, especially under the circumstances. These are our contact details for the STEM lockdown school. These are our contact details. This is where you find us, where you find more information. Anything you want to comment on, we will catch you on these hashtags. We'll catch you on these handles. Thank you, guys. Have a fantastic weekend. Wishing you love, light, and peace of mind. See you on Monday. I'm Miss Shabalala. Bye, guys.